Hello, my name is Beth Dixon, and this is a presentation on quadratic functions and a lot of different things about the quadratic functions and how to graph them. This presentation is designed to be used as a supplement and does not replace your classroom lectures and instruction. It is meant to be and used as a supplement. Nothing replaces your classroom for your learning. So let's look at a quadratic function. And let's first of all look at our function. With function notation, whoa, look at that funky F. With function notation, remember we use f of x to give it a name, and that's nothing more than that name in a naming notation. So don't let that throw you. That is the same as if I put a y equals here, and we can think of it as the same notation. And then our function that we're going to be looking at in this podcast is x squared plus 4x minus 5. And as we look at this, the first thing we want to find is we want to find the vertex. And to find the vertex, we want to label our A, our B, and our C, which are the coefficients or the number parts that are in front of the x squared, the x, and the number part of our quadratic. If this was in general terms, this would be like y equals ax, whoops, got ahead of myself there. And let me go on and apologize for the pen coming down there. Nothing we can do about that. Ax squared plus bx plus c. That's the general quadratic, where a is the number that's in front of the x squared term. So in our case, a equals 1, b is a positive 4, and c equals negative 5. And as we can stop and look at this point, our A is a positive 1. So this means that A is greater than 0. That means A is positive. When I say A is greater than 0, that's the same as saying A is a positive number. And if A is positive, that means my graph will face upwards. It will have a upward facing parabola as its graph. So back to the vertex. My formula for finding a vertex is x equals negative b, or the opposite of b, divided by 2 times a. And I like to look at this negative b as making it the opposite sign of whatever b is. So if b is 4, my b down here will be the opposite of that, or a negative 4. And then 2 times whatever my a value is, which my a value is 1, and 2 times 1 is 2. And 2 divides into negative 4 and leaves me negative 2. This part right here, x equals negative 2, becomes my axis of symmetry. It is the line in which the parabola has symmetry. It's the line in which I could fold up the parabola and it would be the same and make a fold and match on either side. And I'll come back to this and explain this more as I get to the graph. I'm going to find some additional information before I pull into the graph. But this is the axis of symmetry, just the x part. Remember that if we have x equals a number, that this makes a vertical line. If I graph it, and I'm just going to come over here and do a really rough sketch, that this comes out 1, 2 on the -2 and becomes a vertical line, and my parabola is going to match up on either side of this vertical line so that I can fold it in half and it matches. Now the vertex though is a point, and it is either a low point or a high point, and since this parabola faces up, the vertex will be at the bottom of the parabola and will be a minimum of the parabola. And so I need a point, both an x and a y. Now remember that f of x is the same as a y. It's just the difference in notation. We can label it either way. So I need to plug in the -2 in place of the x to see what value of y, or what output, corresponds when x is -2. And so I'm just going to label it y because that's the number I'm looking for. I do need to use parentheses. Remember, when you square a negative, if you intend that negative to be included, which we do because it's a -2 that I need to square, I need to include the parentheses, especially when you're using your calculator. So that's -2 in parentheses squared plus 4 times -2. And I didn't need those parentheses. I just got started and finished them up. And you can use your calculator to do this, since I am doing this visually for you and you can't see the calculator. I'm going to go on and just work this out so that you can see the process and see how we get -9 as the answer. But generally you can just put this into the calculator and go straight and get the -9. And then this gives me my vertex, which the vertex, and watch me, I can't even spell vertex today. Let's try that again. Is going to be the point -2, -9. And I'll graph that here in just a minute after I get some additional information. Some other information that's good to graph is the X intercepts. Now I'm going to write down my function again because I'm going to lose it when I arrow down to do that. And this time I'm just going to leave it as y equals x squared plus 4x minus 5. And I'm going to arrow down, so we're going to lose that top a little bit. Okay, so that's my original function. And now I'm going to find the x intercepts. And to find x intercepts in any function, to find the x intercepts, we let y equal to 0. So we'll put 0 in place of the y, and solve for x. And since this is a quadratic, what I'm going to do is I'm just going to put equals. I like my equals 0 over here on the right. I'm going to reach up here and change to my eraser and erase that on this side. Because I prefer my 0 on the right hand side. Now, that's a quadratic. I could use the quadratic formula, or because I prefer factoring, I'm going to solve this one by factoring. What are the factors? Well, to get the x squared, I need an x in front of both parts. What multiplies to give me 5 and subtracts to give me 4 would be 5 and 1. Because the last term's negative, I need one sign of each. The larger of the two factors will be a positive. The other one will be a negative. That way they multiply to be a negative 5. And when I multiply it back, I get a positive 4x. Then each factor is set equal to 0. Solve each equation. And I have two more points. In this case, the X intercepts. I'll have 5, 0 and 1, 0. As well as the x-intercepts, another good point to find would be the y-intercept. And to find the y-intercept, we want to let x equals 0. And so we'll get y equals 0 squared plus 4 times 0 minus 5, which gives me y equals 0 plus 0 minus 5, which gives me y equals negative 5. And that gives me the point 0, negative 5. Now we're ready to put these points on a graph. And I'm going to move my graph into view. And as I said, we're losing some of this as we're arrowing down. I can't get all of this onto my graph at once. So you may want to rewind if you don't quite remember where we got some of this information. And watch it again, but I'm going to graph these points. The first one was the vertex. Which was the point -2, -9. And we're just going to come over here, -2, -9, and draw a point. And then we have the x-intercepts, which were x equals 1 and x equals -5. And remember, that's where it crosses the x-axis. So that'll be on 1 and on -5. I kind of got out of order there because I really wanted to talk about that axis of symmetry. And I don't like spelling, and I'm a math teacher and like abbreviations, so I'll call that AOS. And the axis of symmetry is a line, and what it does is it goes through the vertex, and it's a line that's not part of the graph, but it's that, again, that imaginary fold line. So some teachers will want you to graph it in, some teachers won't. I'm graphing it in for emphasis here to explain. So I'm just kind of making a little dotted line through that area. Okay, and then our y-intercepts, which was -5, and so that's at -5. Now, because of this symmetry, we can use a little trick, and some of your teachers will show you this trick and others won't. But there's a nice little trick with this symmetry. Do you see how that's 2 units over from that line of symmetry? If you draw that line of symmetry in 1, 2, I can know that because of that symmetry it will match up and give me another point 2 spaces over, and there'll be a point there to match up because there's a reflective point, and that's a nice big word for a math term, but there's a mirror image on the other side here because every point's got to have a point that matches on the other side. See how the X intercepts do that? 1, 2, 3 units, 1, 2, 3 units. So they match up on either side, so we can do that. In addition to that, if you go to your Y equals button on your calculator and type in the equation and then go to your table and get some ordered pairs from your table. And if you need some help doing that, you can check out some of the podcasts on how to enter functions into your calculator. But using your calculator, you can also get some additional points like -6, 7, which would be -6 up 7, the -5, 0, which we've already have on our graph, the -4, -5, which I already have on my graph, the -3, -8, -2, 9, which is the vertex, -2, -9, which is the vertex, and -1, -8, which will also be on the vertex. Now, I've tried to freehand this graph and it doesn't come out, so okay, I've resumed the taping. I had to stop there to get the parabola drawn. It's not something that's easily drawn freehand, and so I had to get it drawn, and it's still a little rough. Just bear with me. But that's then you just connect the points and draw it. And that's your parabola. And again, notice that the vertex is here at the bottom at -2, -9, and that will be a minimum value. Some of the other questions that will get asked about quadratic functions include domain and range. And to keep from losing my graph here, I'm going to just kind of erase all this information over here. You can always rewind and watch it again if you need it back. But the domain of any quadratic function is always all real numbers. There are 2 things we're not allowed to do in the real number system. We're not allowed to divide by 0. And we're not allowed to take the square roots of negative numbers. So our x's cannot be in a division, and we can't have square roots that would allow our x's to be negative. Well, with a quadratic function, neither one of those cases occur. We don't have any, with our function here, f of x equals x squared plus 4x minus 5. We're not trying to divide by an x, and we're not trying to take a square root of x. So the domain of any quadratic is always all real numbers. The range, which is the y value, what y values do we have can be seen by looking at the vertex. The range are the y values. And again, if you look at the domain, that's the x values, you'll notice that the quadratic or the parabola goes out left and right a little bit further, and so it expands on the x's. On the y values, the y values continue to go up continuously, but there is a minimum value. In this case, that minimum y value, because that minimum point is -2, -9, the smallest the y can be is that -9. There are no values smaller than -9. So the range is y is greater than or equal to -9. Again, for the range, you look to the vertex and the y value, and you look to the y value of the vertex, because it's that y value that will tell you what your value is. And because we have an upward facing one, it will be greater than those values because they all go up from there. In addition to that, we can also ask about where is my graph increasing and where is my graph decreasing. Well, to do that, I always draw in that dotted line for my axis of symmetry. And with that axis of symmetry, it is, remember we said, at x equals -2. And that is about the x value of the vertex. Now, that divides the graph into 2 points. This axis of symmetry does. It divides it into 2 sections, not 2 points, excuse me, in 2 sections. And it divides it into the left side and into the right side. And if I follow this graph on this side, and I follow the graph and put my finger on it or the pencil on it and follow this graph, notice this graph is going down, or the y values on this graph are going down. That means on this side the graph is decreasing until I get to the vertex. Then it's flat or levels out. And then on this side the graph is going up, or it is increasing. It changes at this vertex. And we need to be able to describe that. And there are a couple of ways that we can describe that. One way is with an inequality, and it again has to do with this x equals -2. With increasing and decreasing, we want to describe it with x values. Because the y values are changing, we cannot the y values are what we're just saying are increasing or decreasing. We then want to use the x values to describe when the y values are increasing or decreasing. So as we look at this, then on the left hand side, x values over here are all x is less than -2, and over on this side the values are greater than -2. So where is the values increasing? Well, the values are increasing when x is greater than -2, and they're decreasing when x is less than -2. You could also use interval notation, remembering that negative infinity is to the left and positive infinity is to the right, and increasing then would be from -2 to positive infinity, and both of those would be open intervals, and it would be decreasing from negative infinity to -2. From to negative infinity up until you get to this line. Lastly, and I know this is getting to be a very long problem, but lastly, let's look at the discriminant and yes, I have to look up on how to spell the discriminant. We do not want a misspelled word for all the world to see. The discriminant is that part of the quadratic formula that is under the square root. And remember a minute ago I said that we cannot take square roots of negative numbers. If that discriminant was negative, we would have no solutions for our answer if we solved this particular quadratic. Well, we know that there were solutions for it. We got 2 solutions, and there they are. So because this graph crosses 2 places, we know that there were 2 answers, and therefore this discriminant had to have been a positive answer. And you can tell just by looking at a graph that if it's positive, you get 2 answers. If this discriminant's negative, you get no answer. And if that discriminant is 0, you get 1 answer. And for more information on the discriminant, look on the podcast that just looks at that. And I know this podcast was long, but I wanted to do just one example where we talked about all the different things about a quadratic function, because I know that that's one of the main questions, especially as students review for the final, that they really struggle with. And I hope this was helpful. If you need some additional help, please stop by the Math Lab in the Math and Behavioral Social Science Building, room 222. We'll be glad to give you some additional help. Thank you.